This video is intended to provide additional information for trained and competent users of acetylene and oxygen and doesn't replace practical training. Users must always understand safety regulations regarding the use of oxygen and acetylene cylinders and associated equipment relevant to the intended application. Safety instructions related to oxy-fuel applications can be found on the Air Products website. Hello, in this video I'll show you the safest ways to handle acetylene and oxygen in oxy-fuel processes. Before going into detail about the application of gases, let me remind you of regulations for safe transport and handling of cylinders. More about the subject can be found on the Air Products website through the links we'll provide later on in this training. For now, please remember that regardless of which acetylene cylinders you choose, Air Products recommend that you always transport cylinders securely, in an upright position, in an open back vehicle. For internal transport, always use a trolley and secure the cylinders well. Acetylene is a very useful gas, but can cause dangerous situations if the correct safety procedures aren't followed. Acetylene is not compressed like other gases. This is because it's reactive and can decompose into its basic elements of hydrogen and carbon. When this happens, a large amount of heat is generated, and this can start a chain reaction. When that happens inside a cylinder, it can rupture. To prevent this decomposition, acetylene is traditionally dissolved in a solvent called acetone, although other modern solvents are now also used. The cylinder is completely filled with a porous material like this known as the mass. The porous mass and the solvent work together to prevent decomposition of acetylene inside the cylinder. If the cylinder were to be dented, it's possible for the internal mass to become damaged. For this reason, it's important to protect cylinders from heavy impacts. You should always ensure that the cylinder is safely secured in storage, in transport and when in use. You must always treat an acetylene cylinder with great care. The pressure in an acetylene cylinder is relatively low. This means that when the cylinder valve is opened, the gas flow is weaker than from an oxygen cylinder. When the withdrawal rate is too high, solvent can escape from the cylinder along with the acetylene gas. The solvent will burn and you'll see the flame quality deteriorate. It can also block the internal filters within the system, as well as damaging seals, diaphragms and hose linings, which can potentially further reduce the flow rate. It's important to ensure that you don't set the flows too high on acetylene tools to avoid pulling the solvent out with the gas. Typically, the maximum withdrawal rate is taken to be 1/7 of a full cylinder capacity per hour, as you can see in this table. Air Products supplies both oxygen and acetylene in our unique Integra cylinders, our safest cylinder yet, which includes an integrated regulator. A flashback arrestor is designed to prevent a flame front returning to the cylinder. So with Integra cylinders, you can be sure that this essential safety item is always used every time. Later on, we'll show you how to safely connect an oxygen cylinder, like the Integra we're showing here. As mentioned earlier, the key to getting good results when using acetylene gas is to never exceed the maximum withdrawal rate for the size of the cylinder that you're using. The flow rates when brazing and gas welding are generally relatively low, so any size of cylinder can be used successfully. However, when you're cutting, heating or gouging, you need higher flow rates, and it becomes important that the nozzle site is not greater than the maximum recommended for the size of cylinder being used. We've mentioned flame deterioration as a result of wrong settings. In a worst case scenario, the wrong settings can lead to a flashback in the hoses or even in the cylinder. That's why flashback arrestors must always be used, and we'll come to this later. Suppliers of nozzles provide guidance regarding the correct pressures and flows to use with each cutting nozzle size. Having the right equipment is very important. If any equipment's damaged, it shouldn't be used and should be replaced. You must never attempt to repair any equipment that's used with oxygen or acetylene. Let's look at some of the equipment you need when using oxygen and acetylene. There are oxygen and acetylene regulators, flashback arresters, hoses, the torch, and some tools like a spanner and spark lighters. You'll also need personal safety wear or PPE like this: leather gloves, welding goggles and clothing to protect against heat and fire. The equipment should meet the required national standards. Now we're going to set up the equipment. Before you light anything, you must make sure that everything is connected correctly. You must check for leaks and then purge the system. I'll show you how to do this in a moment. If you don't follow this procedure, there could be a leak and a fire endangering you and others around you. The cylinders must be upright and secured. Check the identification label and check the outlets of both cylinders are clear of dirt, oil or grease. We cannot repeat this enough. Never use oil or grease to lubricate parts such as the threads on the regulator or the flashback arresters, as oil and grease can cause an explosion reacting with oxygen. Ensure that regulators are fit for purpose and within manufacturer's recommended replacement period. An oxygen regulator and equipment is always in blue. Acetylene regulators and equipment is always red. A standard oxygen regulator has a right-hand thread and the acetylene regulator has a left-hand thread in the UK, identified by the notches in the connecting nut. Regulator types vary between European countries, so please ensure your equipment complies with local safety legislation. Flashback arresters must be fitted to each of the regulators. These are important safety devices designed to prevent flames returning into the cylinders. We spoke earlier about our Integra cylinder, which includes a built-in regulator. This port on the Integra cylinder is only for air products to fill the cylinder. With these cylinders, users have the added convenience of a quick-fit connector which incorporates a flashback arrestor. These cylinders have the added safety benefit that no additional equipment such as regulators is required, and they can't be used without the built-in flashback arrestor. The quick-fit connectors are colour-coded, blue and red respectively. For increased safety, it's not possible to connect an oxygen quick-fit flashback arrestor to an acetylene cylinder or vice versa. Next, fit the hoses. Hoses come in various bore sizes and lengths and are again colour-coded, blue for oxygen, red for acetylene. Both hoses should be fitted with non-return valves and secured by machine-fitted connections. Reusable worm drive clamps should not be used. Non-return valves will only allow the gas flow in one direction, so it's important to fit them to the torch. Inspect the hoses for any visible damage such as cuts, cracks or burns. If you find any damage, you must replace the complete hose and don't try to repair it. Connect the cutting torch and pressurise the system before use to ensure the system is leak-free. We recommend setting the pressures to 0.3 bar for acetylene and 4 bar for oxygen. All joints should be checked using a suitable oil-free leak detection solution, not soapy water. Any leaking joints caused by loose fittings should be tightened. If the equipment is leak-tight, close both cylinder valves and then open both torch valves to release pressure in the gas hoses. This also will remove any particles present in the hoses. Close down the gas regulators by turning the pressure adjusting knob in an anti-clockwise direction and close the valves on the torch. We've shown the setting up procedure. Now we're going to light the system. Whenever you light up, you must first purge the system, even if it's only been turned off for a short period. Purging is extremely important as it removes flammable gas mixtures from the hoses and equipment. This operation should only be carried out in a well-ventilated space. If this step is not carried out, there's a danger of flashbacks and backfires when lighting the torch. The lighting up procedure is described in detail on the Air Products website. The regulator pressure control knob should be closed. That's in the fully anti-clockwise position. Check that the torch valves are closed. Open the cylinder valve slowly to avoid the sudden pressurization of the regulators. Next, set the required operating pressure for the size of the nozzle you're using. This information can be obtained from the equipment manufacturer's operating data tables. For the cutting nozzle we're using here, the operating pressure for acetylene is 2 psi or 0.14 bar. Then adjust the regulator pressures accordingly. Open the acetylene valve at the torch and allow the flow of acetylene to purge air out of the hose and equipment. Reset the pressures if necessary and close the acetylene valve at the torch. Next, set the oxygen regulator to the correct working pressure. Here we're setting the pressure to 40 psi or 2.8 bar. Open the oxygen valve at the torch and allow the gas flow to purge the oxygen hose and equipment. Again, reset the pressures if required and close the oxygen valve at the torch. Open the acetylene valve on the torch and ignite the gas using a spark lighter. Open the valve further until the flame is flaring and the black soot has virtually disappeared. Then slowly open the oxygen valve on the torch until the correct flame is obtained for the process. This is how it should happen, but what if there are problems? If you get a sustained backfire in the torch, you'll hear a popping, squealing or machine gun fire sound. You should first close the oxygen valve on the torch to prevent internal burning and then immediately shut off the acetylene torch valve. A more serious problem you may experience is a flashback. This is when a flame front moves back through the blowpipe body into the hoses and the regulators and may also reach into the cylinders. A flashback has two components. It creates a flame front and a pressure wave. The flame front moves with a speed of 1400 miles per hour or over 2,200 kilometers per hour, and a non-return valve will not stop it. Flashback arresters in both the oxy-fuel and oxygen lines must protect the regulators and the cylinders. If you get a flashback situation, close down the oxygen valve on the torch first, then close the acetylene valve. Next, carefully close both cylinder valves. If the flashback arrestor didn't stop the flashback, then the flame front may have entered the acetylene cylinder. Now check the cylinder for hot spots by running a bare hand over its surface. If a hot spot's detected or the cylinder begins to vibrate, treat it as if it's been involved in an external fire. Do not attempt to move the cylinder, evacuate the area immediately and call the emergency services. When you've finished working, close the acetylene valve on the torch and then close the oxygen valve on the torch. Next, close both the oxygen and acetylene cylinder valves. Then open both torch valves to vent the pressure in the equipment. Close the regulators by winding the pressure adjusting knobs anti-clockwise. Close the torch valves, then safely place the torch to one side. Don't ever hang a hot torch next to any cylinders. As is the lighting up procedure, the closing down procedure is described in detail on the Air Products website. Before we finish, one last important point on safety. Never use oxygen to blow down overalls or workbenches at the end of the job. Apart from the risks from 200 or 300 bar cylinder pressure, oxygen increases combustibility and will cause the most unlikely of substances to catch fire. Well, that's it. If you use it correctly, acetylene is a very effective and safe gas. If you follow the advice we've shown you, you can be confident that you're working to the best practices.